Hello, we're now at the last video of this section, animating with OpenGL. In the previous video we looked at creating 3D histograms. In this video we'll see how to animate with OpenGL to enhance our 3D visualization. We'll first generate a dataset and create functions for Plot3D. We'll import the MLab source object and use points and scalars features to set particular values. If you've never used OpenGL, we'll now try to give you a quick introduction, although to really understand OpenGL, at least one complete course needs to be viewed. So, OpenGL is a specification, not an implementation, and OpenGL itself doesn't have any code, while the implementations are libraries developed according to the specification. These are shipped with your operating system or by vendors of graphics cards such as NVIDIA or AMD ATI. Moreover, OpenGL is concerned only with graphics rendering and not animation, timing or other complex things that are left for additional libraries to pick up. Since OpenGL is a rendering library, it does not know what objects we draw on a screen. It doesn't care if we draw a cat, a ball, a line or all of these objects. So, to move a rendered object we need to clear and draw the whole image again. To animate something we need a loop that draws and redraws everything very quickly and displays it to a user, so that the user thinks she sees an animation. Let's now talk about the OpenGL installation. So, installing OpenGL on a machine is a platform-dependent process. On the Mac OS X, OpenGL implementation is part of the OS upgrade, but development libraries or headers are part of the Xcode development package. On Windows, the best way would be to install the vendor's latest graphics drivers for your graphics card. OpenGL may work without them, but you'll probably be left without the latest features with stock drivers. On Linux, if you're not against installing closed-source software, there are vendor-specific drivers downloadable either from the distro's own software manager or from the vendor site as an installable binary. Standard implementations are almost always Mesa 3D, the best-known OpenGL implementation, which uses Xorg to provide support for OpenGL for Linux, FreeBSD and other similar operating systems. On Debian/Ubuntu you should install these packages and their dependencies. After this you should be ready to use some development libraries and/or frameworks to actually write OpenGL-backed applications. Since we are focused here on Python, we'll overview some of Python's most used libraries and frameworks that are built on top of OpenGL. Let's now mention Matplotlib and its current and future support for OpenGL. So, first is MayAVI, which is a library specialized for 3D. Next is Piglet, which is a pure Python library for graphics. And third is Glumpy, which is a fast rendering library built on top of NumPy. We already installed the MayAVI package in this section before. So, Specialized Project MayAVI is a full-featured 3D graphics library, which is mainly used for advanced 3D rendering. It comes with already mentioned Python packages like EPD, though not with a free license, which is a recommended way of installing it on Windows and Mac OS X. On Linux, it can also be easily installed using pip. MayAVI can be used as a development library/framework or as an application. The MayAVI application comprises a visual editor for easy data exploration and somewhat interactive visualization. So you can write the code and create your file by choosing the new text file in the File tab from the menu bar. As a library, it can be used in a similar way to Matplotlib, either from the script interface or as a full object-oriented library. Most of the interface is inside the MLab module, to be able to use that interface. Let's now take an example to see a simple animation with MayAVI. We generate a dataset and create a set of functions for X, Y, and Z to be used in the Plot3D function for start position of the figure. We then import the MLab source object that enables us to manipulate our plot on the level of points and scalars. We then use this feature to set particular points and scalars in the for loop to create a rotation animation with 100 frames. Let's run this file and check the output. So, in order to run this file, you need to go to File in the taskbar and select the option Run Python Script. Go to the directory where you've saved your Python file, Select it and click on Open. As soon as you click on Open, our code produces this window with a rotating figure. Amazing! Let's enhance our knowledge with some additional information. So, if you want to experiment more, the easiest way to do so is to load IPython, import mayavi.mlab and run some test_star functions. To see what's going on, you can use IPython's ability to inspect and explore Python source with this code. We can see here how, by adding 2 question marks after the function name, IPython found the source of the function and showed it to us. This is true exploratory computing and is often used within the visualization community because it's a fast way to get to know your data and code. In this section, we first saw how to create 3D bars, and then we created 3D histograms. Finally, we went ahead and explored animating with OpenGL. In the next section, we'll look at plotting charts with images and maps.